Hi friends, welcome back to our series of sessions on Mission Motivate Million Minds. Today, let's know all about National Science Day, which is celebrated all over India on 28th February, basically on the Raman Effect, which brought Sir CV Raman's Nobel Prize winning discovery. National Science Day, celebrated on February 28th every year in India, commemorates the groundbreaking discovery of Raman Effect by the legendary Indian scientist Sir CV Raman. It's a day dedicated to celebrating the spirit of scientific inquiry, innovation, and discovery that has shaped our nation and continues to propel us forward. The Nobel laureate Sir CV Raman, the duration was from 1888 to 1970. I propose this evening to speak to you on a new kind of radiation or light emission from atoms and molecules. With these prophetic words, Professor C.V. Raman of Calcutta University began his lecture to the South Indian Science Association in Bangalore on March 16, 1928. Raman proceeded to describe the discovery that resulted from a deceptively simple experiment conducted far from the great centers of scientific research in the Western world. The results would capture the attention of scientists around the world and bring many accolades, including the Nobel Prize, to their discoverer. Educated entirely in India, C.V. Raman made his first trip to London in 1921, where his reputation in study of optics and especially acoustics was already known to the English physicists J.J. Thomson and Lord Rutherford, who gave him a warm reception. Raman's specialty had been the study of vibrations and sounds of stringed instruments such as the violin, the Indian veena and tambura, and two uniquely Indian percussion instruments, the tabla and the mridangam. But it was the return trip to London, from London to Bombay, aboard the SS Narkunda, that would change forever the direction of Raman's future. During the 15-day voyage, his restless and probing mind became fascinated with the deep blue color of the Mediterranean. Unable to accept Lord Rayleigh's explanation that the color of the sea was just a reflection of the color of the sky, Raman proceeded to outline his thoughts on the matter while at sea and sent a letter to the editors of the journal Nature when the ship docked in Bombay. A short time later, Raman was able to show conclusively that the color of the sea was the result of the scattering of sunlight by the water molecules. Ironically, it was exactly the same argument that Rayleigh had invoked when explaining the color of the sky. The blue was the result of the scattering of the sunlight by the molecules in the air. Raman was now obsessed with the phenomenon of light scattering. His group in Calcutta began an extensive series of measurements of light scattering primarily by liquids, but also by some solids. As a result, Raman was able to explain the blue color observed in the ice of alpine glaciers. Raman effect basically involves the scattering of light by molecules, provides insights into molecular vibrations and rotations, the fundamental tools in spectroscopy. When light interacts with matter, we all know it can be absorbed, transmitted, or scattered. With Rayleigh scattering, most light is scattered with no change in energy. In fact, the Raman effect came a shift in energy. A small fraction of scattered light experiences a change in wavelength. This indicates an exchange of energy between photons and molecules. Which Stokes scattering, we normally call it as photons loses energy of longer wavelength, and anti-Stokes scattering means photons gain energy, which are shorter wavelength radiation. The Raman effect, discovered by Sir CV Raman in 1928, is a phenomenon that occurs when light scatters off molecules. With the light scattering passes through a transparent material, most of it continues straight through. However, a small portion of the light is scattered in different directions. Sir C.V. Raman found that some of the scattered light experiences a change in wavelength. This change indicates that the light has exchanged energy with the molecules of the material. Essentially, when photons interact with molecules, they can either lose or gain energy, resulting in a shift in light's wavelength. This discovery provides a valuable insights into the structure and properties of molecules. The Raman effect has led to the development of Raman spectroscopy, a powerful technique used to identify and analyze various substances. It provided further proof of the quantum nature of light. In simple terms, imagining shining a light through a substance. The Raman effect tells us that some of the light will bounce off the molecules inside. When it does, its color, that's a particular wavelength, might change slightly, revealing information about those molecules. Analysis of light scattered by a liquid is not any easy task, and much of the early work in Calcutta was done by the visual observation of color rather than precise measurement of the light's wavelength, as we are seeing in this color. When white light comes in here, it splits it into VIBGR, ranging the wavelength in the electromagnetic spectrum from 350 nanometers to 700 nanometers, which is the visible spectrum of light, and 1 nanometer equal to 10 power minus 9 meters. The fundamentals of Raman crucial experiments are outlined in this figure. The violet light of solar spectrum is isolated with a violet filter and passed through the liquid sample. Most of the light emerging from the liquid sample is the same color as the incident violet beam, the so-called Rayleigh scattered light. However, Raman and K.S. Krishnan were able to show that some of the scattered light was a different color, which they could isolate by using a green filter placed between the observer and the sample. The advantage of using a visual observation is that several substances can be studied quickly. In his first report to Nature, titled A New Type of Secondary Radiation, Raman indicated that approximately 60 different liquids had been studied and all showed the same result. Some scattered light had a different color than the incident light. It is thus, Raman said, a phenomenon whose universal nature has to be recognized. The significance of the Raman effect was reckoned quickly by other scientists as the Raman spectroscopy, which became a powerful tool in analyzing the wavelengths of scattered light, creating a Raman spectrum. His work revolutionized our understanding of light and matter, with each molecule has a unique Raman spectrum. Professor R.W. Wood of Johns Hopkins University cabled Nature to report that he had verified Raman's brilliant and surprising discovery in every particular and every very particular. It appears to me that the very beautiful discovery which resulted from Raman's long and patient study of the phenomenon of light scattering is one of the most convincing proofs of the quantum theory. That was the comments of Professor R.W. Wood of Johns Hopkins University when he cabled the information to the Nature. Raman had also recognized that his discovery was important to the debate in physics over the new quantum theory because an explanation of the new radiation required the use of photons and their change in energy as they interacted with the atoms in particular molecule. Raman also knew that there was a more important result, remarking in his 1930 Nobel Prize address that character of the scattered radiations enables us to obtain an insight into the ultimate structure of the substance. In the first 7 years of its discovery, Raman effect was the subject of more than 700 papers in scientific literature, mostly by physicists who are using the technique to study the vibration and rotation of molecules and relating those phenomena to the structure. At the same time, chemists became interested in the Raman effect as an analytical tool in the form of, as in the words of James Gibbon's words, the Raman effect became the adopted child of chemistry. By the late 1930s, the Raman effect had become a principal method of non-destructive chemical analysis for both organic and inorganic compounds. The unique spectrum of Raman scattered light for any particular substance served as a fingerprint that could be used for qualitative analysis, even in a mixture of materials. Further, the intensity of the spectral lines was related to the amount of the substance. Raman spectroscopy could be applied not only to liquid but also to gases and solids. And unlike many other analytical methods, it could be applied easily to the analysis of aqueous solutions. It was a ubiquitous technique, giving information on what and how much was present in a plethora of samples, which revolutionized the pharmaceutical drug analysis. In his 1928 talk in Bangalore, Raman concluded, "We are obviously only the fringe of fascinating new region of experimental research, which promises to throw light on diverse problems relating to radiation and wave theory, X-ray optics, atomic and molecular spectra, fluorescence and scattering, thermodynamics, and chemistry. It all remains to be worked at." 70 years later, scientists are still actively working out the results and practical applications of Raman's deceptively simple experiment. And the application of this Raman spectroscopy can go for in fundamental interactions of hydrogen bonding with water structure, ionic liquids, and mixture with water. Number two, it is used in applied in material science to study of carbonium materials, 2D dichaloglycerides, and archaeological materials. Number three, in food analysis of dairy products, honey, coffee, meat, and testing. It is widely used in forensic science of anti-crime, document examination, identification of drugs, detection of explosives. It is very quietly used in biological applications of biomolecules, cancer detection, diabetes, and virus identification. And Raman spectroscopy is also most widely used in environmental monitoring, in identification of nuclear material, pollution detection, and natural gas. And its most versatile use is in art conservation, basically in identification of pigments. The Raman shift is very significantly used. These are the words of Sir C.V. Raman while he was after receiving the Nobel Prize. In his own words, I quote, "When I sat in the crowded hall and I saw the sea of Western faces surrounding me, and I, the only Indian in my turban and closed coat, it dawned on me that I was really representing my people and my country. I felt truly humble when I received the prize from King Gustav. It was a moment of great emotion, but I could restrain myself. Then I turned around and I saw the British Union Jack under which I had been sitting, and it was then I realized that my poor country, India, did not even have a flag of her own. And it was this that triggered off my complete breakdown." These are the words of Sir CV Raman when he received the Nobel Prize. Today, as we stand on the threshold of a rapidly evolving world, the importance of science and technology cannot be overstated. From the smartphones in our hands to the medical advancements that saves lives, science is woven into the very fabric of our daily existence. It is the engine that drives progress, the key that unlocks the mysteries of the universe, and the tool that empowers us to build a better future. Sir C.V. Raman's journey is a testament to the power of curiosity and perseverance. He demonstrated that even with limited resources, a brilliant mind, driven by passion and purpose, can achieve extraordinary feats. His legacy inspires us to question, to explore, and to never stop seeking knowledge. It reminds us that scientific excellence is not confined by geographical boundaries or material possessions, but rather by the sheer force of human intellect and dedication. In India, we have a rich history of scientific achievement, from the ancient mathematicians and astronomers like Aryabhatta and Brahmagupta to the modern day pioneers in the fields like space exploration and biotechnology. We must build upon this legacy and cultivate a culture of scientific temper among our youth. National Science Day is not just about remembering the past, it's about inspiring the future. It's about igniting the spark of scientific curiosity in the young minds present here today. I urge each one of you to embrace the spirit of inquiry, to ask questions, to experiment, and to never be afraid to challenge conventional wisdom. The world faces numerous challenges from climate change to energy security to healthcare and food sustainability. These challenges require innovative solutions, and it is you, the young scientists of tomorrow, who will be at the forefront of finding those solutions. Remember, science is not just about memorizing formulas and theories. It's about applying knowledge to solve real world problems. It's about creativity, collaboration, and critical thinking. Participate in science fairs, engage in science projects, and explore the wonders of the natural world. Let us all pledge to foster a scientific mindset, to promote innovation, and to empower the next generation of scientists to make India a global leader in science and technology. On this auspicious occasion, I wish you all a very happy National Science Day. May your scientific journey be filled with discovery, innovation, and success.